Perfect. Okay. Good morning, Michelle and East Doncaster Secondary College. It's Christina. Lovely to see you. I think you're on mute. Good morning.
Good morning. It's PLC here. I'm just trying to work out how to change the name for you.
Oh, fabulous. It's in the top right-hand corner. There's 3 dots and you can change your name. Can you see the 3 dots?
Oh, that says view. Oh, there. A rename. Thank you.
You're very welcome.
PLC will do.
PLC will do. Perfect. Just to know that we can see who you are and I can call you into the class.
Now, here's
Lovely to see you.
here. Hi, ladies. Say hello.
Good morning, everybody.
Now, why is that not projecting onto the screen?
Now, whilst you're setting up, if you wouldn't mind just putting yourself on mute and then all the other groups will join us.
Yeah, it's not coming up on.
If you wouldn't mind just putting yourself on mute while you're sorting out your...
No, it's the system is not, I've got it on the screen so the kids can see you easily, but it's not, same system. Try that.
So whilst you're sorting that, if you wouldn't mind just putting yourself on mute, that'd be great. Thank you. Good morning, Marcelin Randwick. Lovely to have you join us.
Morning.
Michelle, good morning. If you wouldn't mind just changing the name on your video so that we see that you're East Doncaster. Everyone's tech working, everyone comfortable? Perfect, thank you. We're very excited. We'll start right on 9. We're just making sure all the schools can jump in and they can see us. We're very excited for the day. Fantastic. So ideally, if you've got the opportunity, your students can either join the Zoom link or they can watch from the projector that you've got hopefully in the classroom, and then the computer can be turned around so that we can see the students working. And then they're very welcome to come to your computer and add to the chat as questions come up, or you can add to the chat. I'll call schools in as the day progresses, but if there's chat, there's live chat with our keynote and our engineer, with myself. Good morning, Keenan. Good morning. Keenan Secondary College, good morning. Hi, lovely to see you. Welcome to our fabulous lab. Wonderful. Tech's working. We'll join the session very shortly. We're just waiting for everyone to join. Thank you so much. Good morning. I've got a number on screen. Could we change our name so that I can see who's participated, please? Are we all ready to go? We've got our kits ready. Everyone excited? I've got some videos up and working, which is fantastic. So I'm just going to ask one of the schools participating. I've got a number up, but I don't know which school it is. So I'm just going to put in the chat that if we wouldn't mind just identifying the school, please. Good morning, everybody. Great. Almost ready to start. Still waiting for a couple of schools to join us. Good morning, Betsy.
Welcome. Oh, it's so exciting to see all these students all ready for EV Day.
It's so great. PLC is sitting there waiting. East Doncaster College sitting there waiting. Koonung, very exciting. So we're just waiting on a couple of others to join. We've got 1, 2, 3, 4. We've got 3 more schools still to join us. So hopefully they'll join in really soon. I know Ashfield has just contacted me, so they'll be in very shortly. Koonung Secondary College, would you like to put your camera on so that we can see your fabulous students ready to go? And also Marcelin Randwick, that would be great if we could see you and your students. Everyone's looking pretty excited. Perfect. Thank you very much. Look at them all waiting very patiently. Super excited, Betsy. Look at them. Very excited. They're all very well-behaved students too. Okay.
Yes, they are.
So I've admitted again. Oh, we've got another school. Okay, so could we have school number? You've given me a number, which is great, but could we just write the school name? So on the top right-hand corner, there are 3 dots, and you can change the name of the video. If we'd like to write the school name, that would be fabulous.
While you all are waiting very patiently as we get the rest of the schools in here, if you all want to start thinking about if you could have any vehicle in the world, what would it be? Feel free to have your teacher drop that in the chat for us because I'm so curious what all you guys would buy if you had any kind of money at your fingertips.
That's a fantastic question. I don't know what I would buy.
I know, right? It's a good one. How about
It's a really good question. It's like, oh, what would I buy if money was no object?
Betsy, mine would definitely be a convertible.
Oh, that sounds good. Right now, I don't know if it's nice where you all are, but it's been so gorgeous and sunny lately. A convertible would be perfect for today's weather.
Well, it's freezing here, but I think a 2-door Maserati convertible would also be fabulous, I've got to say, regardless of the weather.
Betsy, are we talking electric vehicles?
It can be electric vehicle. It doesn't have to be. Since we are here for electric vehicles, I'd love to know your favorite electric vehicle too, as you're thinking.
Oh. Good morning, Kamal. Lovely to see you. Would you mind changing your video and your participation name to the school that you've got, please? The top right-hand corner, there are 3 dots. If you wouldn't mind just changing your name, that would be wonderful. Electric vehicle. I've been looking at purchasing electric vehicle lately, actually. I actually drove a hybrid car in Europe about a month ago, and I drove a fabulous little MG. It's a hybrid. It was really fun.
Oh, I love MGs.
It was zippy. It was fantastic. Good morning, Marcelin Boulain. Hi, everybody.
Oh yeah, I see some waves. Hello.
Hi. Wonderful. Thank you for joining us. Okay, we've got 1, 2, 3, 4, 5, 6, waiting on one more. Ashfield Secondary College, Ashfield Boys High. Could you please just put your camera on and change the name of your video, please, of your camera so that we can see the school name?
Yes, I'm doing very soon because my boys are coming. Give me like 5 minutes, please. By that time we'll do it.
Okay, come on. Thank you very much.
I need preparation. Thank you. Thank you.
Okay, so if everyone is almost ready, if we could have our cameras on. So that we can see your fabulous students. Now, has anyone got any cars that they'd like to put in the chat like Betsy asked? This session is so much better if everyone's fabulous. Thank you, Kamal. That's wonderful. If everyone is interactive and participates in the chat, wonderful. Thank you.
Yeah, speaking of Christina, I used to have a Toyota Camry hybrid and I loved it. I had it for like 15 years. If I were going to get an EV, I'd probably get a Tesla just because they're so prevalent around where I am now. But there's some others out there that are pretty exciting too. And we get to look at some of those today, which is so fun.
So excited to do that. So, and I'd also love to know a little bit, because I am looking at cars. So the difference between hybrids and plug-in hybrids and all electric vehicles and the differences, because it's really confusing if you're looking to buy cars and you hear all these information.
Boys are here. Yeah, guys, can you please settle down?
Wonderful. Would you mind just putting yourself on mute, please, Kamal, just whilst you're getting yourself sorted? Ashford, thank you. Thank you very much. So, Betsy, back to that, if, to know the difference between them all would be really handy too. So I'm hoping that some of these fabulous, clever students have got some really engaging questions.
You're right. I am looking forward to that. And I'm looking forward to talk about all the components that go into these electric vehicles too throughout our lab today.
Absolutely. Okay, so we're still waiting on one school, but I think I might just give them a quick email, but I think we might start really soon. So I'm just going to pop myself on mute for 2 seconds whilst I contact this school, and I'll be right back.
I think they're excited, Betsy.
I was just thinking that. I see some excitement. I see some waving. I see some excited faces and smiles. I cannot wait to engage with you all today. This is going to be awesome.
I think you've got the perfect audience.
Okay, I think we might just start, and then if the other school comes in, they can pick up from where we are. So good morning, everybody, and welcome. Welcome to Marcelin Boulain, Marcelin Randwick, East Doncaster Secondary College, Ashfield Boys High, PLC, and Koonung Secondary College. We are absolutely delighted that you've been able to join us for this very special lab day. We are super, super fortunate to have Constance Chiplock from Engineering Tomorrow in the US. We have Betsy Fortin, aerospace engineer, who will be conducting our workshop today. And we have Angus Cheek from BAE Systems Australia joining us a little later to talk about his personal journey into engineering and what his pathway looks like now. Today is a real opportunity for you all to participate in a really exciting virtual lab, but also the opportunity to see where an engineering pathway may actually lead you. You'll be able to listen to a presentation, you'll participate in design and build and testing of your own EV vehicle, and you'll be able to hear from a graduate about what life looks like through schooling, through secondary, tertiary, and also what life looks like and what his pathway and opportunities are available to him and what he's most excited about being an engineer. You'll have the opportunity to apply problem-solving skills, which hopefully will lead you to understand what these skills look like to solve problems in the real world. So things like creating bridges to link remote communities, or it might be looking at food and water systems for rural environments, like EVs today. It's looking at an environmental perspective and being a little bit more renewable and clever with our energy systems so that we can be a little bit conscious about our environment going forward. There are lots of opportunities, whether it be Wi-Fi, whether it be EVs, whether it be bridges and all sorts of engineering pathways. So today I really would like you to enjoy, sit back, listen, learn, ask lots of questions. So welcome again, and Betsy, over to you.
Fantastic. I couldn't have said it better myself. So, all right. Well, we get to jump right in today to our electric vehicles. And you guys, you know what? It is our first lab of the year here in the United States, and you get to be with me. I feel like I hit the jackpot today. So thank you so much. All right, we're going to run through this agenda really quickly. We're going to start off here. You're going to learn about electric vehicles. Then we're going to build, and we're going to jump right into building. So I'm super excited for those things that we get to work on. All right, we talked a little bit as we were waiting for schools to dive in here with us, but what are some examples of electric vehicles? What things come to your mind? Please feel free to unmute yourself, shout it out, or have your teacher type it in the chat for us, because we would love to hear what you're thinking about when you think about electric vehicles. And some of you may be thinking about electric vehicles maybe on other planets, maybe. Those are where my mind ends up going, but that's just my aerospace background. All right, I'm going to give you a half a second here to think about some electric vehicles. Yes, Ashfield boys.
Put your hand up, sir. Electric cars.
Can you say one more time?
I think your mic works. Can you hear us?
It's very faint. If you can just relay it again as the teacher, that would be really helpful.
Electric buses.
Oh yeah, that's a good one. Yes, high five to you. Drones, Audi e-trons, Tesla. Oh yeah, look at you guys. You are rolling them in now. I love it. So good. And you know, the student who had just said electric buses, that is such a good one, because it's usually not right at the forefront. At least here in the United States, we don't have the greatest public transportation systems across our country, but I know lots of other countries do. And so it's really important to be thinking about, how do we convert some of those from our internal combustion type of engines over to these electric ones? So that was such a great answer. So you guys have hit some of these already, which is really cool. So the electric buses, the drones, you can see down here the trolleys, electric streetcars, some really good options. Raise your hand. Does anyone have one of these? So you guys have electric bikes or maybe an electric scooter? I'm curious. Oh, I see Christina's got one. Any of you students out there? Did I see any? Okay, so maybe you guys use some electric scooters and things like that. And then of course, in this middle, right down here, you can see satellites. So those are my specialty and my favorites, of course. Some real world applications, or out of this world, if you want to think of those. The International Space Station, you can see over here on the left. And then over here on the right is the Soyuz. This is the Russian vehicle that we used to fly our astronauts up and down with the Russians when we retired the shuttle. actually, it was my job to go over to Russia with our astronauts and train our astronauts and the cosmonauts on all the different space station systems for the International Space Station as well as the Soyuz. And so you can see these things here. These big long arrays, they kind of look like these wings. In fact, we call it the solar array wing. That's what's going to be getting all the solar energy and then being stored in batteries. And guess what? Just like the vehicles you're going to make today, those batteries help to run all the systems that are needed, both to keep us in flight, but also to do all the operations, to run our fans and the circulation and all the computers that go into the International Space Station. And you can see the little solar array wings here on the Soyuz as well. But my favorite electric vehicle, I gotta say, I did not work with this one, but it's my favorite, and it's Perseverance. Raise your hand. Who here has heard of Perseverance? Oh, yeah, I see some hands. So Perseverance is like a drone. It's a helicopter running on another planet. And I could not give you the exact number of flights that it took before it shed a blade. It was somewhere around, I want to say 72. Don't quote me on that though. And I just find it so fascinating that in our lifetime, a helicopter was operating on another planet using the same principles that we're going to be applying today. So let's jump in. You heard a little bit about me. I've been working in the space industry since 1995. Do not calculate my age because it's older than I like to think about. I mentioned these two vehicles that I helped to train our astronauts on. When I came back from Russia, I had been over in Russia about 6 years at the time when I was training our astronauts and flight controllers. I came back and joined the astronaut office as their chief engineer for exploration. What this meant was I got to analyze all the different vehicles that came after Space Shuttle. So if you've ever heard of Orion, that's this capsule here. This is the one going to the moon and Mars. And then SpaceX and Boeing. I had the opportunity to review their early designs and the requirements and make sure that they were satisfying what we call something human rating of a vehicle. And then my most recent adventure, I guess I would call it, is working with Solvik Synergistics as we were applying human design. So how a human can operate a given vehicle. For example, if they have to be able to reach a certain valve to open up a line, can they reach that valve? Or do we need to maybe redesign so that it's in a more prominent area and things like that? So you can see that space station over here as well. So today we're here to learn about electric vehicles on our planet though, to start. But of course, I don't want you to limit your thinking to just our planet, because what you do today, you could apply to anything. And I think that is so cool. So let's listen to a little bit of history about electric vehicles.
I was invited here to Munich by BMW, the sponsor of this video, to find out why the future of cars is electric.
But electric cars are actually nothing new. They date back to 1832, well before the first gasoline-powered car. In fact, the first car to go faster than 100 kilometers per hour was, in 1899, an electric one, called the Jamais Content, meaning never satisfied. But people were, apparently, satisfied with electric cars. By 1910, they were almost twice as common on American roads as internal combustion engines. But then came the Model T, which at $650 was significantly cheaper than comparable electric cars. And as gas stations popped up around the country, they could be quickly refueled, allowing you to travel farther, faster, and cheaper than electric cars, which took a long time to recharge. So by 1935, the electric vehicle had been commercially obliterated. But electric cars were still useful for some things. In the vacuum of space, an electric vehicle was the obvious choice for the Apollo lunar roving vehicle. It was a single-use vehicle due to its non-rechargeable silver-zinc-potassium hydroxide battery, and it had a range of just 92 kilometers. But the astronauts never needed even half of this range.
Okay, I'm not going to have you watch the entire video here, but I'm curious, was anyone surprised by anything? Raise your hand if you were surprised by anything in that video. I know I was. Yeah? All right. So if you're willing, what were you surprised about? I can give you one that I was surprised about. I was surprised that we had electric cars before we actually had what we call internal combustion engines. You might hear it called ICE or ICE, internal combustion engine. But that was a shock to me when I first started doing this particular lab. I was surprised that we actually used electric vehicles. Anyone else feel like that was something that they did not know? Anybody? Oh, okay. Y'all are so smart out there. Okay, very good. So I'm curious, what do you think might be a benefit of an electric vehicle? I know you all have really good ideas out there. Feel free to unmute or have your teacher type in the chat. What might be a benefit? Like, why would we want to use an electric vehicle? Oh, yeah, there we go. East Doncaster. Yeah, 0 emissions. So good. So we want to save this planet, right? And we don't want to be having gasoline and all of the exhaust that comes from it. Yes, Ashfield Boys, sustainable. Yes, sustainability. How can we, make sure that we're using our resources? Oh, yep, East Doncaster, right? You're right again. Using our resources in a creative way that we're not depleting our world, right? So many good answers out there. As you think of them, drop them in the chat. I have multiple screens and I can keep watching your answers as we continue to. All right. So a few of you have already hit on some of these. Cheaper to fuel up, high five to you. Yes. Safer, awesome. Oh my goodness. You guys have so many great answers. So on the left, you can see what a typical ICE internal combustion engine has. On the right, you can see electric vehicles. What are you noticing? Right off the bat, what are you noticing just in quantity of things? Yep, I am guessing you guys are noticing yes, East Doncaster. Yes, it's mechanically simpler. These electric vehicles have fewer parts, as you're noticing on your screen right now. And what that means to you is less things to break, right? And so when we're thinking about how our electric vehicles work, we have the ability to reduce the number of parts that we're using and to make things mechanically simpler. So that was such a great answer. Anyone else have any others? So let me see. Marcelin, I hope I'm not mispronouncing that school. You had the answer that it is cheaper to fuel up. You are right on with what our next slide shows. The cost of fuel. And fuel feels like a funny word, right? So when we talk about fuel, we might be at our brain thinking about gasoline. However, when you actually compare what it costs per dollar, so let's say $1 in order to travel in an electric vehicle, we can go 30 miles per $1 in an electric vehicle. And you can see that is much greater than our internal combustion engines or the ICE engines over here. So that was such a great answer. System can be smaller. Oh, another great answer. Yeah, the system can be smaller because we have less parts. And therefore, if we have a smaller car, I'm guessing you're already thinking there's probably less mass, which means it's a little bit lighter weight, which means it's probably easier to even make go, right? As you start looking at your cars today, you'll be building, and the lighter weight you can make it, the better, because you'll be able to use that propulsive force to get you moving. A couple other things that you might not have thought about is regenerative braking. So this is using the energy that the car is actually stopping and kind of reverse engineering that to use that energy back in the car as well, and to be charging your battery from that. So that's another really good one. Idle off, the EV battery will turn off when the vehicle is at stop or idling. You've probably seen this or heard this as you come to a stop, all of a sudden it gets really quiet in an electric vehicle. And that's another reason. And here you can see that regenerative braking that we were just talking about. So one thing that hinders me let's say, is how do I charge it, right? Like if I need to go across the country, can I do that? Well, over the last 5 years, I feel like it's really exploded over here in the United States. Give me a thumbs up. Has it been exploding over there too in Australia? Have you seen more and more electric vehicles popping up? Yeah. Oh, thank you for the thumbs up. I see it. Very good. So yeah, it's becoming more and more affordable and more like sustainable. You can see down here our map of all the different charging stations. But not only that, it used to take like 12 hours or something crazy to charge the car. Nowadays, they have these superchargers and they can supercharge a car in 15 to 45 minutes. And I don't know about you, but I don't mind if I'm taking a road trip and I've already gone a few hours, popping out of my car for 15 minutes, right? Not a problem. And so it's getting easier and easier with all of the different charging stations, as well as the speed that we can charge them with. So that's another great thing happening. Here are some other things to think about. So these batteries, right? This is where I hope you all will help bring the world forward. I feel like our limitations right now are the batteries. How much charge can they hold? How long and how far can we go on one charge? So right now we typically use lithium ion batteries. You can see compared to like the internal combustion engines using the lead acid batteries. What you'll see in this chart, you don't have to study all of it, but what I want you to take away from it is the number of times you can cycle a battery. You'll notice down here, these lithium ion ones can cycle in big amounts, correct? And then the other thing, the capacity that it can hold the charge, they're getting better and better, but it's what's limiting us from going further and farther in our cars. And so I challenge you, as you're thinking going forward, if you're interested in electric vehicles at all, consider how to make batteries even better with different types of materials, and you will definitely be changing the world. So cool. All right, so what are we here for? We're going to be working in our lab today, as with all of our labs. It's all about this engineering design process, right? We just learned a little bit about how electric vehicles work. We look at the design, and we're actually going to design our own. And I'm challenging you all, if you can, have at least one of your people in your group that will actually draw out what your design should be. I feel like this is half the battle, making sure you have a good design to start before you just jump in and start building something. As you build and test it, you're going to find that things are working maybe a little funny here or really good here, and you're going to want to keep iterating on your design to see if you can make the fastest car, or maybe the most sustainable car, or one that can handle impacts for safety. I'll show you some of those challenges coming up. All right, on the screen are some of the components that you're going to get to use. And I'm going to switch my camera real quick here to kind of walk you through what that's going to look like for you. So hopefully, are you seeing my hands? Okay, awesome. So what do you got, right? Like you're going to get these kits and they're going to have some pulleys in here. This is one of the pulleys, some gears. You're going to have some axles. You're also going to be given some straws. I want you to think, what would this straw be used for? If anyone has an idea, drop it in the chat as we continue. You're also going to be given a fan. This can be used as one of the propulsion components. As you probably know, every action has an equal and opposite. I'm cupping my ear. What is that next word? An equal and opposite reaction. Oh, yeah. Okay, and then we have our batteries. So today, we're not using our awesome lithium ion batteries. We're just using our regular alkaline batteries for our packs today. But we have a double holder pack. We have a motor, and you guys get to decide, what am I going to do with that motor? Okay, so on the screen, you can see there's actually 3 different types of cars you can make. You can make one that is propulsion driven by your turbine, your gears, or your pulleys. So I want you right now, raise your hand if you think you're going to go ahead and use the propeller. Is that you? You're going to use the propeller? Okay, raise your hand if you think you're going to use the gears. Okay, I see some gears. Awesome, awesome. What about the pulleys? Anybody gonna use pulleys? Okay, I see some pulleys. All right, there are some advantages and disadvantages to each of these types. I find the ones that drive the cars the fastest tend to not be this one, but this one is the easiest. So I would recommend you maybe start with this one. And then if you want it to be faster, you can consider going with a gear or a pulley. Now, you can see my car here. This one, I was using it for gears. I don't know if you can see that really good there. There's a gear right there in the middle. Well, what would happen if this gear didn't line up perfectly? What would happen? Do you think it would go? So that's something I want you to think about. How can you make those gears line up so that the teeth end up going together so they're not out here trying to spin and kind of spinning your wheels per se, right? That was a very bad pun. Also, kind of similarly, if you're using the pulleys, you're going to put your pulley system just around here. But what if you're trying to line them up and it's like either too tight and uh-oh, I just broke my pulley, or it's too loose? Do you think your car will work very well? Okay, so those things are some considerations. And my last consideration, I don't want to give it all away to you, but if I'm using the fan turbine as the propulsion forward, what might happen if it's too low or too high? Too high is less of a concern, but maybe too low, I'm running into some design constraints if you can consider that. Again, I don't want to give too much away, as you'll have to be figuring out all of the things I just alluded to as you design your car. All right, I'm going to flip my camera out here 1 second. Once you've chosen which type of car you're making, you get to make the base. Again, depending on what kind of car you chose is going to make how your base needs to be. Do I need my turbine to be higher or lower? Do I need my gears to be lower so that they're along the axle? Think about all of those questions. You also got your axles, your wheels, and how you need to attach them, and your battery pack with your motor. Okay, and again, your motor can drive any one of those 3 components up at the top here. So you get to choose and be the design engineers today, which I think is so cool. Oh, I see some hands waving. Do we got some questions? If you have questions, either unmute or drop them in the chat. I would love to answer your questions. On the screen are a few more examples of what you might design. And here is a video showing someone's testing. And I think you are. And on the screen, you can see someone's testing. And I'm going to challenge you. Can you make your car faster than the one you just saw there? I think you can. I'm excited. Okay, a couple things to think about. Increasing speed with mechanical power, or what we call torque. Oh yeah, Asheville boys, high five. You can make it better. I can't wait to see your designs. Here's something we call mechanical advantage. Notice here, this gear, this small gear, is on the motor. And it can turn, and it can turn pretty fast, right? If it's on the motor. And to get your big, massive car to move, we can use this mechanical advantage where this gear, the bigger gear, doesn't have to work so hard, and yet it gets our car moving. So think about that as you're putting your gears together. And similarly, that same mechanical advantage happens with the pulley system too. Here are a few challenges. If your class would like, you can try to be the fastest. You can try to be the most cost effective. In your workbooks, I believe there are some material lists, and each part costs a certain amount. Can you make your car the cheapest, the strongest, meaning that it can take impacts over and over and over again? How about your massive materials and your aesthetics? So here is a good example of ones that are built for safety and durability. How will your passenger handle a crash test? Or if you're crashing it 5 times, 10 times, 20 times, see how your car works. Does it stay straight after all of those crashes? How efficient can you be? Can you use materials in your class that maybe would make it more sustainable? Things that you'd be throwing away or recycling that you can actually make your car out of. Think about that, as well as some aesthetic appeal. I believe in your packets, you will have these like origami different links where you can make the skin of your car also. And here's one being really out of the box. This was me a couple years ago. I was teaching our 3D printing lab, which is separate from this, okay? But I said, you know what? Can I make that move? And I put the propeller on it and by golly, it moves, you guys. So if you have anything that you might have 3D printed or something that you want to do in the future, definitely don't hesitate to see if you can make it move. All right. I cannot wait to see all of your designs. Thank you so much. Oh, Christina, yeah. Looks like a Cybertruck.
Thank you, Betsy. That was wonderful. Really very informative. Students, I hope you took lots of hints and handy tricks to be able to build and design your own EV. It's now time for you to break into your groups. I'll leave that to be teacher-led, but essentially you'll have a good hour now to design, build and test your EVs. We'll be online to ask questions. I'll call you up as I can see you building and designing. But now you have the opportunity to discuss with your groups, break into your workstations and design and build. Good luck and enjoy. Fantastic, fantastic, Kamal. Thank you. Well done. Thank you, Ashfield. That's great. We'd love to see you. Wonderful, Kuna. Lovely to see you. Look, working really well. Hi.
I see a fan working there, Quinn. Yeah. Look at the motor.
Marcelin Boulain looking fantastic. Lots of busy building at East Doncaster. Good job, people. Marcelin Randwick, lots of busy design looking there. Hi. Discussion and design and build at PLC. Looking great.
Do you guys get your motors working already? Give me a thumbs up. Anybody connect your motor yet? Not yet? Oh, okay. I can't wait to see them. I would say connecting and testing your motor would be the first thing I would work on when you start building, just to make sure that it actually starts up when you connect the battery pack.
So Betsy, what I think you're saying is to make sure the mechanism works before we worry about the design of the outside. So you can design what it sits on and how it sits once the mechanism works.
Yes, that way you know that you've gotten your circuit working. But of course, you can, since you have 3 or 4 people in each group, you could have one set of students working on the motor and one working on the design drawing and that too. So, don't hesitate to kind of break up some of the division of work that has to happen to make your car move.
And of course, there's going to have to be someone who's going to present as well. So someone has to put their hand up to come and talk to us about how it all works and what their process was.
So true.
Looking great, PLC. Is anyone ready to come and share some of their designs up with Betsy, just to have some questions answered or some techniques looked at? I can see some really busy groups building. Does anyone have anything they can share? Great, Ashfield, thank you. I'm going to put your mic on so that you can talk about the process and maybe some questions.
Ashfield, it looks like you got the axles attached very nicely with your straw. Good thinking.
Okay, yeah. Okay. Anyone want to share anything now, boys? What are you up to? Yeah. Okay. All right. Yeah. You want to hurry up to guys, share something, some work? All right. Okay, stay slow.
Yeah, so we can't let them steal our design.
Okay. All right. Yeah. Okay. Yeah, it's still working live. Mr. Hall. I love it.
Sounds good. You've got plenty of time. Just keep on working. We're here when you're ready to share anything.
What a great idea, East Doncaster. Thanks, Michelle.
So the basic idea is that the basic idea is this is where the motor is gonna go. And this is not the motor, you put it back straight. So this is the motor, it's gonna spin this. We're gonna attach another base over there. And that's also that's our basic design, but we're also going to add more stuff.
Looks really nice. It looks very symmetrical, which is so important, right? As you're trying to balance your forces, having nice symmetry in your car is so important. So very nice job. I can't wait to see it when you get it on the base and working. High five to you. Thanks for sharing.
Okay, we're about halfway through the design and build process, so there's another half hour to go. Everyone's working really hard. Designs are looking great. Please come forward and ask questions if you have any questions about the mechanism or the design. All looking really good, but we've got another half hour or so before we break for a bit of a recess. You're obviously very welcome to stay and continue to work through that break, but the break will be in about half an hour.
All right.
Oh, turn around step.
Keep working, boys, keep working.
Turn around step. Step, what's happened?
See some good hot glue guns going. Looks like the cars are starting to come together.
Good, get out of here.
Keep working, that's all right.
God damn.
Look at last one I lock in.
Keep working, boys.
Damn, turn around things.
That car's almost done right there.
This on camera.
All looks fantastic. Thank you so much for sharing.
Good work.
If we don't have a direct question or a show and tell, perhaps we can turn our mic off. Thank you. All looking fantastic. Thank you. Okay, so there's about 15 minutes left of the challenge of design and build. Again, you're very welcome to work through your break, but we'll break at about 10:30 for about 20 minutes, 25 minutes. There's still 15 minutes left of this challenge. If anyone would like to come up and either ask me or Betsy or Constance, preferably Betsy, Betsy has the knowledge, of any design questions or mechanism questions, please come up, put your camera on, put your mic on, and just ask direct questions. Otherwise, we've got 15 more minutes. Can't wait to see everyone's working designs. We are, of course, going to keep all communications respectful and appropriate, aren't we?
I love to see all the thumbs up. I think that means you guys have successful cars. I cannot wait to see it after the break.
Everyone's designs are looking fantastic. Everyone's worked super hard in that hour, sitting at their pods, working super hard. I can't wait. Betsy, I'm so excited. I can't wait to see what they've come up with.
I know, I've only seen
They've
those.
kept their cards very close to their chest, so I haven't seen much.
You're right. It'll be awesome when they actually get them testing against each other. I can't wait. Oh, I
Me
saw one. Marcelin teased theirs right in front of the
They
camera.
did a little bit. Okay, so it's 10:30 now. So those who are willing and able and are comfortable with their design and build, they can go and take a break now. We've got about a half an hour where you can go to the bathroom, leave, obviously it's up to the teacher in charge, but we've got about 25 minutes or so because we'd like to come back by 5 to 11 so that we can start right on 11 o'clock to test and compete against each other, which would be fantastic. And then we'll get into our keynote. So about half an hour off. Obviously, if you're not finished with your design or build, please continue working through. But we'll shut off cameras and mute ourselves an hour for about 25 minutes. By all means, again, have something to eat, go to the bathroom, and come back ready to compete with your spectacular vehicles because I can't wait to see them. Are there any questions before we head off? Their card. They've kept their cards very close to their chest. We've seen very little, prototypes. We've seen nothing. So we're very excited about seeing what they've come up with.
We saw a lot of great building, right?
We did.
I
They
think I
worked
even
really
saw
hard.
on the break there at the end some tabletop racing. Just saying.
I do. I did see some practice runs. I did. Waiting for
Welcome back. Oh yeah, getting some close-up videos. Oh, it's even connected. Look at that one going. Ashfield boys, awesome work.
Excellent. So we're all back. Okay. Do we want to have some volunteers of who would like to go first, or should I just sort of pick you out? Who would like to go first? What we need is some groups coming up, putting their camera on, putting their mic on, showing Betsy their design, their thought process, and then perhaps a test run against either the other groups in the class or just to look at speed. Might be on an incline. Let's have a look. Anyone want to put their hand up to go first?
I think the one at Ashfield. Oh, there's PLC has their hand up.
Perfect. Come on down.
Mute. Okay.
Oh, please.
So there you go. Let's talk about what you've done and then show you.
This is our car.
Very nice.
We made it with motors on the wheels. Motors. Gears and gears.
Very good. Yeah, that makes sense. So you use the motor to drive the gears that are on the wheels. Nice. All right. It looks like we're gonna have a test here.
Okay. Yeah.
Nice. That was smooth.
Girls, you want to keep going? Do you want the rest of PLC at the same time?
Sure, if there's
We've
someone
got
else
three.
that's
Three
ready.
cars.
Perfect. Yeah, that'd be great.
Okay. You want to keep going? Okay, tell us what you've done.
So we made this small one, and then we use mainly gears to like connect the wheels to make it move. Yeah.
Yeah.
As you get this ready. Look how smooth that one is too. That was fast. So I'm curious, ladies, would you come talk to us for a second? Did you try using anything other than gears, or did you say, I'm using gears and just went with that?
Oh, it's just gears.
Just gears, very nice. Did you have any trouble getting the gears to line up at all as you were putting the design together?
Pardon?
Did you have trouble getting the gears to line up?
Oh, yeah. We changed like a few times to like try and make it like fit to the right size.
Awesome. Well, it looks like you nailed it with that one, getting all those gears to work together, fitting in, and I could tell it worked very smoothly. So thank you so much for demonstrating. High five to you.
Thank you. Yeah.
Okay, and we have one more.
Clapping too.
We have one more.
Awesome.
I also did a same sort of gear design as others as well. Yeah.
So we started off working together, and then they've sort of split into slightly different designs. So they made their own cars in smaller groups.
Oh, awesome.
Having had a conversation and worked some things together first, they then went off and did some things individually.
Oh, I
in
love
small
that.
groups.
Can you
Ella,
hold your like this, like towards, so I can see underneath it? Are your gears right next to the wheel?
Can you show her?
Yeah. The
Oh, very nice. Right on the edge there. Very good. Nice job.
It's okay, I'll figure it out.
I really like this teamwork too. Whoa, that one's fast.
Oh,
Did you all see
it's
how
still
fast
doing
that was
circuits of the room.
Okay. Yep.
Very nice. So I'm curious, when you see that one veering off to the left, what might you do to your design to help it stay straight? Is there anything you would adjust?
I think it's like off center. It's like a bit weighed. So it's like going in the opposite direction. So I can adjust it to be a bit more streamlined and like
Like symmetrical, maybe?
yeah.
Yeah, you are talking about one of the best design challenges that we have in every industry. If you think about cars, keeping everything so that all the forces are balanced on the left and the right. The same is true with all of our spacecraft as well. So I love that you've already thought, like, if I shifted it to the left a little to kind of offset the fact that it's going in a different direction. That's so smart. And that's using that design process perfectly. So that was really great. High five to you.
Thank you.
Of course, thank you.
Thank you, PLC. That were fantastic designs, super quick. Okay, do we have another school that's ready to go? Ashfield, I think you put your hand up earlier. Fabulous.
Yeah. So this is our design. It's pretty messy, but hopefully it works. We've tested its work, but almost.
That went pretty straight. Very nice job. All right, can you bring your car back up and show it up? Was that gears or pulleys? I missed it.
It's geared, yeah. It's connected to the gear.
Okay, very nice. I noticed that you have it down the center line. That's very helpful because that gives it that symmetrical feel. And I also noticed that you have it down by the axle. Did you have any trouble getting your gear low enough to get to the axle, or was it pretty easy when you put
No, we use a hot glue gun, so it's pretty easy to get it down on top of it.
Perfect. Very nice job. Is there anything you would change about your design at all?
I think it's a little bit too low to the ground, which sometimes you could then hit the ground and slow it down. So I'd probably bits a bit up. Mainly the bigger gear, it's a bit too low. So I'd probably do that.
Gotcha. Oh, I like it. Thinking about improvements that you might make for the next iteration. Very good. High five to you.
Thank you.
Right, next group.
So
We have
far, all
another
the
group.
kids have been crushing it. Christina, they're doing so good.
Right,
So
come on,
good. The
come on.
designs are really sporty and compact, and they're fast. They've done so well. Another group from Pauline.
Okay.
Okay, so tell me about your design. How did you guys decide to choose the design you use?
Oh, so this is our car. It's pretty cool. It's got like gears and stuff and batteries.
We use the gear design.
Yeah. This is a close up of our beautiful car.
Very
It's very
nice.
even. Nicely built. Yeah, we made it balanced and we use lots of tape to make it aerodynamic.
Okay, trying to streamline this. I like it.
Should I go to?
That was fast. Oh my goodness.
That was fun. That was fun.
And it was straight. That might have been the straightest one I've seen so far. All right, so you
That was really fast.
tape to help it. Now, tell me, what principle
Don't do
are you talking about when you use the tape?
Aerodynamics. You mentioned aerodynamics.
Yeah.
What was the question?
So you were using that for aerodynamics. So I'm guessing that you were trying to reduce some kind of friction from the air on your car, and that tape. Yeah.
It is very frictionless, you know?
Yeah. Thank you, boys.
Very good.
Right, next group. Shannon, you ready? No, thank you, boys. Thank you. Shannon?
Great job. Hello.
That was fun.
Okay, you have a nice flat surface, it looks like.
We've got a cardboard piece over our car as like a bit of aesthetics. We're using gears on the bottom and we've taped the electrics to the bottom as well. So it's a bit cleaner over the side.
Nice. So you have that platform on the top as the aerodynamic streamlining effect, it looks like, and all the components are at the bottom. You know what? In electric vehicles, this is exactly what they do. So they put more of those batteries towards the bottom of the floor of the car, and that helps keep it stable so that it doesn't like tip over backwards or things like that. And it really helps keep cars, when they're in crashes, more stable than standard placement of higher up batteries. So I love that you've thought about that in yours. All right. I am curious. How does it
No, boys. Thank you.
Very nice. Very straight as well.
Right, who's next, boys? Thank you.
Great job.
Are you ready?
So what age group of students is this? Are you freshmen, sophomores?
Year 9 by the look of where you're at. Year 9, year 10 maybe. Is that, I think, so 14, 15-year-olds?
Awesome. Well,
Thank you. Thank you.
Have we got any more groups from Marcelin Bulleen, or are we done?
We're done. We're done. Thank you.
Perfect. Thank you so much. They were really well done. Thank you. Thank you.
Great.
Okay. East Doncaster, are you ready to go? You've got a roaming camera there.
Hi, we're just going to another workshop because the room that we're working in was actually carpeted. So, yeah. Does this group want to go first?
Fantastic.
All right, so we started with a plan. This was our plan. This is the design.
Oh, nice.
We changed it up a little bit. We made it rectangular. And then we made like a small wheel and base in the front. And then we made a 2-wheel drive with 3 battery.
Yeah, we actually.
Very nice. So you changed it from your original design. Was there a reason that you did that? Did you find it was easier to build that way, or did it work better that way?
Dynamic, as it's like thinner, opposed to the thicker box. And we also just found it a lot easier to make this design while it's still also just as effective as our previous plan was.
That is amazing. I love that you guys drew it out first, and I love that you were thinking about not only the manufacturing and creating it, but then also all the effects of like the aerodynamics and the streamlining that you're trying to do too. Perfect, perfect job.
Yeah.
Are you ready?
I'm ready. Whoa.
Stop.
Really nice. Really nice job, you guys.
Which group next? Over here.
Okay, so
You're on.
okay, so we didn't actually have a plan to start with, but that was kind of the whole idea. We wanted to have like a frame that was easy to work with, and to test different configurations. Realistically, we knew that at these kinds of speeds and this kind of weight, aerodynamics is not going to be a major factor. So we wanted to play with how we configured the weight and how we configured the gear ratios. So originally we started off with a pulley system, but we found that it wasn't performing as best because the pulley was slipping. Like the rubber band on the pulley was slipping and it constantly fell off, as well as, yeah, it just didn't deliver the torque that we wanted. So we switched to a gear system in the back here.
Oh, yeah.
And we also added a little crumple zone in the front here just to make our lives easier, and so it won't break when we crash it, eventually crash it multiple times. And yeah, we also tested with different like electrical configurations. However, we just found like the default one with the the 2 series batteries performed the best. So we tried it parallel as well, but it wasn't worth it.
Gotcha. And when you say it wasn't worth it, it didn't go any faster, or you didn't know?
Actually.
Okay. Very good. I love that you added the bumper to the front. So how many times did you crash it on purpose? Kind of like we do crash testing, you would imagine.
On the crumple zone, we didn't want to crash it intentionally. It's just that we had to test it many times and we can't like stop it in time. So we just added a crumple zone in front to prevent it from breaking when we eventually crash it.
Very smart. That's like designing your testing smartly too. So that was really awesome. Have you thought about what you want to do when you get out of high school?
Aerospace engineering, actually.
Are you serious? That's so amazing. Well, looks like you're well on your way. How about your teammates? Anyone else have any ideas what you're going to be?
Automotive.
Automotive engineer or designer.
Very cool.
No, don't know. Should we move on to the next group?
Sure.
Are you
Good
ready,
luck.
boys? You want to move over here?
Hi.
Hello. This is
Oh,
our
wow.
car. It has 3 batteries, but instead of 2, we wanted to maximize the amount of power that we could have. We placed it in different areas just to make the dispersion of the weight more even. It's very like front heavy, you know what I mean? It is based off of an F1 car. We wanted to have good aerodynamics because we wanted good battery efficiency, so we didn't want to use all of the battery very quickly. So it will go pretty fast.
Wow. Did you adding the battery was helpful and made it go faster, or did you find that it slowed it down at all?
We had to like try different combinations with how we connected the wires actually. So yeah, after we found like a relatively good one, it started going pretty fast.
Absolutely. So cool that you thought about the Formula One there. I love the spoiler there as well. Nice job. All right, I can't wait to see this one. And I love that other schools are commenting on your design and they're saying great design. This is so cool getting to see your schools interact together. Oh, look at it. Oh yeah, I think that extra battery did a little something there. Very nice.
Well done. Just going over here. All right, East Doncaster.
Hello.
So this is our electric car. We call it Baby Road G because it's like kids core theme, and it can't really ride on all of the surfaces, which are one of the problems we actually face. It couldn't ride on carpet, and we tried many solutions such as using tape and the cover for it or paper, but we still couldn't kind of solve it. But luckily we're in a room with a flat surface so it can actually ride. And we also use a propeller instead of a gear because we wanted to try something simple so that we can focus on the other problems first. And that is all about our electric.
That is awesome. So you guys learned the surface matters, right? The surface that we're writing on, and that you noticed the carpet kind of gave that extra like friction and made it a little bit harder, kind of like if we were going on a rocky terrain on Mars per se, right? And so you're using the propeller. I love that. I think it's the first one I've seen today in these classes. So super job that you're thinking outside of the box here. Do you want to demonstrate it for us?
Base.
Okay, yeah.
Let it. You gotta put it down on the ground.
I see movement. And we have liftoff. Oh yeah. It looks like it does just fine on that nice smooth surface. That's wonderful. Great job, team.
You guys ready? I think that is all from us from the moment. Maybe come back to us. We might have a couple of cars that are not quite finished yet.
Sounds perfect.
Thank you so much. Really well done. Thank you. Thank you. Okay, so we've got Marcelin Randwick and we've got Ashfield.
All right, let's go back into the other room.
East Doncaster, if we wouldn't mind just putting ourselves on mute. Thank you so much. Ashfield, are you ready to go?
Okay, Ashfield is going to do it now. With the laptop.
We have a few designs here. We have me, Lucas Dwarf, and Lachlan, and also Brendan's son. We've got our first design and our second and third, and these two both use fan power to move their machines or whatever. All right, now we'll do a demonstration of the three moving together.
Hey, race them.
It's almost like a race.
Ready?
Ready?
Three, two, one, go.
Oh, your shit came on.
Hey, no,
Awesome. Did multiple ones together.
You got to put me together. Run it. Yayo!
Whoa. That was fast. All right. I slow down. Is there? Does anyone want to say what worked the best and why it worked the best, do you think? All right. Can I talk about why certain ones went faster than others? Did anyone notice anything specific?
What are you up to, Zach?
What did you notice? The gears go
Thank you.
fast? Did the, I see real-time engineering happening, it looks like.
Thank you so much, Ashfield. Well done. Thank you. Marcelin Randwick, are you ready to go? Marcelin Randwick, awesome. You want to take your mute off and show us your designs. Fantastic. Thank you.
You want to do it? What happened to you when we do it? You can explain it.
There we go.
No, I think they can hear us. Can they?
Yes. Oh, nice.
Just do it. Just wait for the wait. Tell me you're clear the desk. You want to explain what it is? No, we don't need to explain. It's our the Benchmobile.
Wow. Nice. That one seemed like it worked really smoothly. So did you guys have any difficulties as you were building your car at all? Was there anything that you came across?
It was veering to the left a lot. So we had to fix that. And we did by placing just like equalizing each side.
Okay, very nice. So yeah, you have to kind of worry about that symmetry. How did you equalize it out? Did you add more mass to one side or another?
So we use like paddle pop sticks on each side. Originally, we didn't have this top one. So we placed the top one there to make sure that it's even on both sides, so it doesn't twist either way.
Very nice. That's a great design iteration there. Way to go. High five to you.
Thank you. Thank you.
Do we have another school? Another EV from Marcelin Randwick to test? Or another design?
Yeah, got one more.
One more?
Wow, I have seen so many amazing designs today. This was so cool.
So good. I think East Doncaster has one more that we can swing back to, if everyone's happy to swing back to East Doncaster. They had one more group, and then we'll see where we're at.
Sorry, they're not ready yet.
Okay, no worries. I have a couple of slides to share with you real quick, if it helps too. While you're preparing yours, I just wanted to point out, you all have been crushing it today. I have seen so many different designs, gears in the middle, gears on the side, fans, not fans, pulleys tried, so many great things that I have heard. If you are enjoying this, there are several different career pathways that you could take in order to do electric vehicles. So on the screen here are just a few that showcase what is out there in the different paths that you might be taking. Whether you go to like a cert or university, totally up to you and what you're most interested in. A few items on the screen. If you're like, hey, how do I get involved? Guess what? I know here in the States, you don't have to wait until you're already in university or you graduate. You can already start reaching out to these various companies and see if they have any internships, whether they're paid or not. It doesn't matter. I'm telling you, when I first got involved in the space program back in 1995, I was an intern. And I co-opt every other semester. So one semester I'd go to school, and the next I'd drive across the country and I'd go live in Virginia to work at NASA Langley. And it was some of the best experiences I had. I did 4 different rotations. Some I liked, some I really didn't like. But what was so cool about that was I got to understand like what I enjoyed doing, and I could then focus my career on those things that I enjoyed. It also let me know that it's okay not to love everything. And it also helped me understand why I was learning something. If any of you have ever found yourself in a classroom asking, why am I learning this? When will I ever use this? Has anyone ever asked that? I can't be alone. I knew it. I knew it. Okay. So I remember asking myself those questions and thinking like, why do I have to do all this homework? When am I ever going to use this? And then like the next semester, I found myself as we were like putting these sensors underneath the F-18 and then putting it in a wind tunnel and testing it. And I was like, oh my goodness, I understood why we were doing the math problems and the homework problems, because I could see how it applied. And so I promise you, any kind of experience in the field that you're interested in will kind of help solidify and give you that motivation to understand why you might be learning something too. A few items on the screen here. You might be wondering, are electric vehicles always on the ground? As you know from my space presentation, right? You know there's some in space. But did you guys know that there is aircraft that is all electric these days? This is a picture of the E-Caravan, a 750 horsepower electric motor, and it has over 1 ton of lithium-ion batteries. Incredible. We talked about all the charging stations being put all over the United States and other parts of the world to help this become more affordable, also more ease in being able to travel, and also the superchargers that help us charge faster so we don't have to wait so long. All right, so here is one cool thing. The Ohio State University, I'm a little bit partial to because I'm actually from the state of Ohio. They built the fastest ever EV, and I'm curious, does anyone have any idea how fast the Buckeye Bullet goes? So I know it's in miles per hour. However, does anyone think it goes 100 miles an hour? How about 200 miles an hour? Are there any 300 miles an hour takers? Guess what? It goes 321 miles an hour. It's crazy, crazy fast. And they're making them faster and faster every day, I feel like. Before I show this crash testing, I wanted to take a second here and see if that other school had any more that they wanted to showcase before I show this video. Anybody? It was East Doncaster, was it? That might have one more yet. Okay, if you guys have it, feel free just to drop it in the chat and I will pause this at any point. All right, so I love the people that put the bumper on the front part of their car, because guess what? Just like any vehicle, these EVs also have to be very, very compact, but also have to withstand the different forces, not only in normal, like I would call it flight, right? Not motion, but also if there's any kind of impact. So I want to share this video and I want you to watch how these cars kind of react throughout the crash testing. And then I'm going to pause it again. So notice, if you have lots of parts in the front, it would be coming into the cabin where the people are sitting. With the electric vehicles, a lot of these batteries now can be located towards the back and lower to the ground. And then I'm going to fast forward. So I don't know if any of you have thought about this, but as you watch these crash tests, there's all kinds of things that go into engineering, not just the forces and the calculations and all that, but watch these crash test dummies here. They have paint on the face, half red, half blue, so that as the impact happens, do you see what happened here on the very left-hand side of the screen? This means that there was a twist of the body and the person impacted twisting towards the left. And the fact that someone had to think about how can we find out which way the impact is going to cause someone to hit or turn. And I just find this so fascinating because this is, you know, bringing the creative part to the engineering part as well. And I think that's so often underrated of how important it can be. And so I love showing that in this crash test video as well. And today I have certainly seen a lot of creativity, even a face on the propeller of one of your designs. So cool. All right, here are a few skills you've gained today, whether you knew it or not. You were learning about manufacturing. Hey, I'm going to change this design because it's easier to build this way. That was one of the manufacturing and assembly. Battery technology. Those of you trying to figure out what's the best way to put my batteries together, should I add more batteries, etc. And also, as I mentioned earlier, I think the future of electric vehicles is in the battery. The better batteries that you all can make in your future are going to bring the world its future, right? And then one other part that I think is so important that you guys gained today is enhancing your performance of your electric vehicle. So as you realized your pulley wasn't working as well and you switched it to be the gears, as those of you who figured out there is a bumpy carpet, it's not working here, I have to change my testing so that my design will work. All of those things were part of like making sure the performance of your vehicle worked. And I'm just so proud of every single one of you here today. You did amazing work.
Mate.
Oh, Christina, I think you might be on mute.
Sorry, I must have clicked and clicked on again. Betsy, thank you so much. That presentation, the synopsis, the link to everything was just fabulous. Schools were wonderful at the way they presented the design concept, and the link to what you were asking them to do was just wonderful. So thank you so much. Now we've got a really lovely treat. We've got Angus about to join us. Angus, I'll come back to you, Betsy, at the end. But Angus is from BAE Systems. He's a graduate. He's going to join us now to speak about his pathway and his learning. And we can't wait for Angus to join us. So, Angus, have you got your camera on? And
Hello, yes.
Hi.
You can hear me okay? That's the main thing.
We can. Welcome. And I'll let now Angus introduce himself a little bit, but essentially Tasmanian born, studied at the Australian Maritime College and is a naval architect, and is now going to talk about his pathways and his aspirations and all the opportunities in engineering in the way Angus would like to see life for him. So welcome.
Cool. Thanks for having me, everyone. I have been tuning in through the morning. There's some pretty cool designs going around. They look a lot better than my first attempts at some of my engineering designs, even when I was at uni. So the future looks pretty bright, I've got to say. It looks a little bit better than a few years ago. But nevertheless, I'll get started. So first of all, thanks for having me along. So who am I and where am I from? So yeah, I'm Angus. I grew up on a farm up in the northwest of Tasmania. So on the red arrow there on your screen and then map of Tasmania, that's where I'm from. So grew up on 100 acres out there in a beef farm. And then in my part-time, you know, when I'm not studying or when I'm not working or fixing things that I've broken on my car, I like to go fishing. I found the only photo that I had where I've actually caught a fish. I do tell everyone that it's much bigger than that, but you guys get the honest truth here. So bear with me there. While I was in year 11, 12, so I understand you guys, I think, are in 9 and 10. So you're getting up to that point where you get to choose your subjects. So for me, in year 11, 12, I studied physical science. So in Tassie, we do like a prerequisite before we do physics and chemistry. So I did physical science, methods 4, English literature in my year 11, and then I took physics, chemistry, and specialised in my year 12. I took 2 other subjects in my year 11 and year 12, which I really encourage you to do, which is I took subjects that I enjoyed. So I took athlete development in year 11, and I took modern history in year 12. And they were the things that sort of, you know, when you get your level 4 subjects get really heavy and there's a bit of work to it, you're like, oh man, do I have to go to school today? That's when you're like, oh, actually, I've got that fun subject at the end of today. I'm really looking forward to that. And that's what gets you there. That's what gets you out of bed, keeps you going. So I really encourage you to take a fun subject while you're going. But after I did 11, 12, I moved to Launceston. So for those of you who are unfamiliar with Tasmania, I put the other yellow marker up that. So that's where the Maritime College is. So moving on to that, what I studied there was I took maritime engineering. So I understand it's a few aeronautical or aerospace engineers going on in this chat. I'm hopefully going to change a few of you over to be maritime. We'll see how we go. So I specialized in naval architecture. So basically what that is effectively it's like mechanical, like aeronautical engineering, but with the sea. So I can basically work on and design anything that moves in the water, right from the propeller on the back of an outboard all the way up to the entire ship itself, submarine, frigate, whatever you want to do. There's a few defense things for me. Obviously, I work in defense industry. So a little bit about the Maritime College for you. It's an internationally recognized college, and it's actually the only place in the Southern Hemisphere that you can get the accreditation that they offer there. They've got state-of-the-art facilities that BAE Systems, ASC, lots of defense companies, lots of just contractors all have to book into and get the use of. As a student, you actually get to use those facilities right from your first year, as pictured on the screen. So I've actually got two of my mates where they've got those big yellow models. That's worth several thousands of dollars that some company has rung up and gone, hey, can you build us this model and can you test it? These guys have just got one made for them and are testing it in the basin for their assignment. So really hands-on, a lot of design work. You've created your electric vehicles today. We didn't make electric vehicles. We made a thing called a rat trap boat. So that's what the other picture is there. What it is you take a single rat trap and you've got to somehow manage to power it using that rat trap and get it to move. I think it's 10 meters across the model test basin. You do that in, I'm pretty sure it's your first semester or second semester of uni. So get right in there, right into that design spiral, get right into doing things, which is really, really cool. One of the other, probably my, I don't know, kind of my nerdy little thing that I like about the Australian Maritime College is we've got the cavitation tunnel down there, which is a big, basically big circular pipe, which goes about 3 or 4 stories high. And they fire water over the top of propellers. So as pictured in the screen there. And what that's doing is testing the propeller tip vortices that are generated as that propeller is going to sail through the water. So for the likes of submarines who, you want them to be quiet, you want them to sneak up on the big destroyer, you don't want the destroyer to find them first. For that, it's really, really cool. You can actually get down there, you're in there, all the lights are off, and then you're watching this water getting pumped over the top of the screen as these propeller tip vortices are being generated. And normally it's meant to be top secret. Again, I would go down there for my lunch and go and chat to the lecturers down there, and you'd be sitting in there watching it happen. So really, really good experience. Really encourage you to do maritime engineering. I'm not trying to poach anyone or anything. I am. But yeah, so the other thing too, while you're at the college or while you do any uni degree, and this is something that I really encourage engineers to do, is take the time to go to social events. Take the time to network. That's something that you'll do as you learn, is that you do your theory and you learn how to be an engineer, but it's also networking and meeting other engineers or just meeting other people, because the engineering industry, though vast, it's actually very, very small. And so all those networks and all those friendships you make, that's the main thing. And at the end of the day, you're there to graduate, which I've put the old photo up there of my friends and I. We were fortunate enough to actually get asked to carry the flag through Launceston and lead the graduation team last year. So that was a really good experience. So I guess, yeah, what do I do now? I work at BAE Systems, based here in Osborne over in Adelaide. So up there on the screen with the red arrow, that's my little old office. So to give you a bit of perspective, I'm in there now. The building just down the way has got with the big orange doors there. That's about 13 stories high. So in that, and it's about 13 stories high, a couple 100 meters long, and it's basically like a garage for ships. And so effectively, they're just literally building a ship, putting in there. We'll sail it down and park it right out into the channel, and then hopefully it floats. That's the main thing. But yeah, so I work on the Hunter class frigate as shown on the screen there. That's the big render. That's one that's still being built. Fingers crossed it gets there eventually. But as well as that, part of my work, it's a lot of design, a lot of sitting around a computer, mostly doing analyses, looking at the stability, the seakeeping, and managing how the ship's being built. But on top of that, because we need more engineers, because we need more naval architects, they're sort of desperate for us to be, or they need us to sort of jump projects. So I was really lucky, and I actually got on board a destroyer earlier this year, which is HMAS Hobart, and that sailed in in July, actually, or June, sorry. And yeah, I sailed from Sydney up in New South Wales, and then sailed all the way down to Adelaide, and that was about a 7-day voyage. Great food. There's a photo of me. Oh, that's the best photo I could get because they're all protected by the defence. But that's me down in the Bass Strait there. And no, that is not Tasmania. It is a little bit bigger than that. But hey, I'll let you go with whatever it is. But yeah, being on board that ship, you get to learn hands-on, and you get to learn from the people that use the ship. That is the best place that you can learn anything. Is from the people that are going to use that ship, the people who are going to live on it every day, the people who deal with all the problems that us as engineers, maybe we don't think about when we're doing our really cool designs and making our race cars and stuff. You know, we want it to make it go fast and be awesome, but at the end of the day, people are going to use it. We want it to work, right? So that's my work at the moment. I love it. And yeah, I think as you guys as engineers, you're really at the theory bit at the moment. But with engineering, it just gets more and more practical. And what I always found, I always struggled to read books and stuff for a really long time. But what I've found with my work is that now that I've got something to apply it to, and I've got something that I can see being built, that application process, it's like, I think about it all the time. I'm so excited. So it's a really, really good career. But I guess just another question is, are there any opportunities besides desk work? So I'm actually really glad that I got to do this presentation because it meant that I could reach out to my friends who I graduated with last year. And so I asked them to provide me with some photos of what they're doing now. So these guys in this photo, we've got our main photo there with the dark background. That's actually one of my mates, Valentino. He's working night shift on an offshore oil rig out in Western Australia somewhere. He works 6 months of the year, 6 months he has off and goes forward driving. He works out there as an ocean engineer, so he's helping manage the structure and help the divers who go down and survey the sides of the oil rig and make sure it's not going to fall over in the ocean. Another one, my mate Sam Woolridge, he's primarily based up in Broome, and so he works all offshore, and he's been working to install a jacket structure crux off the coast of Broome at the moment. And then the last one, if you guys have got really keen eyes, you might be able to pick out Sam Brooks, just down on that lower screen there. He's on the barge. And so he was the one in charge of balancing out that barge there to make sure that 100, I think it's 200 meters by about 80 meters wide, that jacket structure, to make sure that it's not just going to fall off. You know, I don't know if any of you have stood on board a ship, but it goes and rocks like this. So to have 25,000 tons on board that barge was a little bit of a, you know, I think they broke the tug, but everything else went well. So happy days. So yeah, to summarize, I don't know if you can tell how excited I am, but I love engineering. And I've just put up some useful tips. So if you're all asleep, now's the time to wake up. Just to summarize, if you want an awesome career, either as a naval architect or as an engineer for that matter, these are my 5 top tips. So number 1, balance your study with a fun subject or a hobby. Any day, anywhere, that's the best thing you can do. You always want to be balanced. Don't want to be burned out. You want to be able to give your best in everything, but also come home with a smile. That's the number 1 thing. The other one is, with your subjects, don't fret. This goes for physics and chemistry as well. Check your prerequisites for what your degree is. And when you go to uni, they actually sort of go over it again, specialized maths, or they go over physics, or they go over chemistry. What that does is just it sort of takes a little bit of the load off when you first get to uni. But if you've got a lot of work on, or maybe that hobby is, you know, you're playing football or something and it takes a little bit of your time, it's okay. You don't have to do the harder subjects to do really well. And I've had mates that actually didn't do any of the hard subjects coming in 5 years later after they've had a bit of a gap year that turned into a 4-year holiday, and they've still managed to come out as very well-rounded individuals and very good engineers. So it's really worth it. But then that then leads into my point 3, which is hard work pays off. I think Betsy mentioned it before, you know, that study that you do, you think, whatever, you know, that test, that study that I've just done, that maths that I did, it's not going to matter. And then 2 semesters later, it's like, oh, there it is. Oh, this is great. You know, I know what I'm doing. And all that hard work carries into what you're doing as an engineer later on in life as well. So the more work you do at your age now, through your uni, and then you come out as an engineer in industry, you've got the confidence to be able to take it on and just get into doing whatever it is that you're really interested in. Number 4, make most of the social events. The networks that I've got now from being at university, being even in through year 11, 12 and that, I had a few international friends that did boarding school days as well. By being sociable, by meeting all these sorts of people, I've now got contacts all around the world. And at the moment with BAE, I've actually got friends, you know, that work in other contractors that BAE contract out to. And so you'll jump on a Teams meeting, you'll turn your video on, you're like, hey, I know that guy, you know, sorry, how are you going? Blah, blah, blah. So it makes it really friendly, it makes it really fun. And yeah, it just gets you going to work every day. I mean, that's what you're here for, to make friends and have fun. So, and number 5, this is my favorite one, be an active learner. Look for opportunities, always look for opportunities. And if an opportunity presents itself, jump on board. For me, it was jumping on board the Destroyer. You know, I get awfully seasick, terribly seasick. I get motion sick in an elevator. That's a fun one. So I was like, oh, am I going to do this? Am I going to do this? I just said, no, I'm going to jump on board because this is such a good experience and such a good learning experience. And I'm really, really glad that I did it. So just little things like that. Do an extra test. Push yourself to do that extra maths. Look to join the choir. Something like that. Something different. But all of that, you learn different things and you learn different skills. So it's really, really powerful. So thanks for listening to my spiel. I hope you've learned something or maybe taken something away, but I've put up a QR code on the screen if you'd like to learn more about maritime engineering. But otherwise, does anyone have any questions for me?
Angus, I got one for you. How did you decide to go into that type of engineering?
Well, that is an interesting story. I'll give you the short version. So when I was in year 11, 12, I was dead set on being a mechanic and then maybe playing football and not doing engineering at all. But I actually busted my ankle and had to crutch down about 300 steps before I found a very small tent that had AMC on it. And I spoke to the maritime engineers in that tent for probably 2.5 hours after I'd just had surgery on this ankle only a few weeks before. My mum did drag me by the ear down to this open day, by the way. So I very much so credit her to that. But I spoke to those guys down there, and when they talked to me about maritime engineering, I practically lit up, apparently, is what my parents said. To one of the harshest environments on Earth, I suppose you work a lot in space, one of the harshest environments on Earth is the ocean. And obviously a lot of it's been unexplored and there's all these different designs you can do. You know, you're not just stuck doing a little dinghy or something. You can work on a big destroyer or a frigate like myself, or you can work on submarines that operate under the water. Or then even some engineers, they told me a story about how they'd actually designed an underwater restaurant up in Norway. And so there's one up there. I don't know if I'd be that keen to go to the underwater restaurant, having known some of the guys I've graduated with, but you know, still. So it's that diversity and that ability to just go and do whatever you'd like. That's what really attracted me to it. So, yeah.
Very cool.
Thank you.
Just fantastic, Angus. Thank you so much. Students from any of the schools, does anyone have any questions? Angus is certainly very enthusiastic about I love it. Just having that energy and passion for what you do is just so inspiring. And I'm hoping some of the students have really picked up on, between you and Betsy, who just seem to love what you do, are so engaged with what you do. Betsy has a plethora of experience, but just that love of learning, as you said, and that hard work ethic is something hopefully all the students will take away. Hopefully in the field of engineering, but in any learning that they do and in any area that they learn in. Angus, again, thank you so much. Your passion and energy for engineering really has shone through, and hoping now students have got a little bit more understanding of different pathways. It's fabulous to see the aerospace engineering component from Betsy, but to also see another component, and also for the students to understand that there are multiple pathways. So thank you again. Before we finish up, I'd like to say a big thank you to Constance for assisting in the organisation and the mentoring from me. Betsy, your presentation is always fabulous. Engagement and the engagement with students was just wonderful. Angus, again, thank you very much. I think, do we have some slides maybe of photos that the students did in terms of participation, just so that they can see themselves participating? But what will happen from now on, I think, is we will wrap up very shortly. I will send through to schools the recording of this workshop so that all students can have a look at it, but also students who weren't able to participate on the day can go through and perhaps build an EV at a different time. And then also for staff to keep an eye out for our next fabulous our next fabulous Engineering Tomorrow workshop, which should happen towards the end of October. So by the end of the week, you'll get some communication from me about what steps are next.
So good. Yes, Christina and Angus, I loved listening to your presentation because your excitement is contagious. And just like you were saying, when you're doing something you love, work is not work. It's enjoyable. And I hope that students will find they enjoy just as much as you. So well done, Angus. Thank you so much. And look at what all of these students did today. This is so cool looking at what PLC was designing, Ashfield Boys. We've got all kinds of amazing designs that were happening in these classrooms throughout. And even some of the active tests, I think I was able to snap a few pictures of as well as you are all showing off your designs, the spoilers, the different battery designs. Oh, so awesome. I couldn't have imagined a better way to spend my evening than to be with you all. So thank you so much.
Thank you, Betsy. Thank you very much. Thank you, Angus, and thank you to all the schools who've participated today. Keep an eye out for any communication that's coming from me in the next couple of days, and enjoy the rest of your day. Thank you very much.